So, good morning, guys. So, for this moment, we're going to have now the first session for our synchronous class for this fourth grading period. But before we start, let me check my audio and visuals sa ating channel. This one, I was not able to have the synchronous class at exactly 9:30 because I will have separate meeting for that one. But anyway, so in this case, pwede nyo naman pong panoorin ito during our respective schedule para at least is lalabas pa rin na synchronous class pa rin po tayo. Okay, so far okay naman yung aking visuals and audio sa ating YouTube channel. Again, streaming across our screen. For your attendance, kindly type your surname sa ating comment section. And also, if you have questions that you want to be answered, please put that one on our comment section. I will try my best to answer that one through our Facebook GC or group chat. Okay? So, just give me a minute. So, I will be starting my presentation na rin. So, let me... I do hope that my screen is now up and running sa ating YouTube channel. Okay? So again, good morning my dear grade 10 students. Again, this would be our first session for our online class. Tandaan lang po natin, 2 linggo lang po ang ating online class in actually to uh, to lessen the risk natin lalo't sa mainit na panahon na ito. So for our topic for the day, we're going to have kinetic molecular theory. So medyo mabusisi rin ito because this one is actually it's actually a long topic. After this, we're going to discuss gas laws, then chemical reaction, sunod-sunod na po yan. Now, while we are having online class, focus lang muna tayo sa lecture. Yung mga lab activities natin ay sa pagbabalik na lang natin sa face-to-face after, I think it will be June 5, kung hindi ako nagkakamali sa ating schedule. So without further ado, let's start now. So the topic outline for our session today would be the overview of physical states and gas pressure and its measurement. So titinan natin ngayon, babalikan natin ngayon sa session na ito, yung differences ng solid, liquid, and gas para ma-facilitate din yung ating learning ng ating topic for this session. So let's have now the first topic, the overview of physical states. So I do hope na alam ninyo po yung ating the regular states of matter na alam natin. We have the solid, liquid, and gas. Okay? So most substances can exist as a solid, a liquid, or a gas under appropriate conditions of pressure and temperature. Ibig sabihin, for example, the best example would be our liquid. If yung water natin, yung H2O natin, if that water is placed in an environment wherein the temperature goes below 0 degrees Celsius, your liquid water will become solid ice. But if your liquid water was placed or is placed in a condition wherein the temperature and even the pressure is so high, for example, 100 degrees Celsius or more, your liquid water will now turn into gas. So technically, lahat ng material na alam natin will have this phase change given the appropriate conditions of pressure and temperature. Even the metals that we know, even the solid things that we know can change into solid, liquid, and gas as long as the appropriate conditions of pressure and temperature are given to that material. Okay? So, basically, I do hope na alam niyo na rin po ito, yung mga basic structure or yung particle structure arrangement ng ating solid, liquid, and gas. So, yung ating solid, liquid, and gas natin, very obvious naman yung sa ating solid, the particles are very near to each other, while liquid material will have at least a little bit of space or little bit of give sa pagitan ng mga molecules na yan. And for the gas molecules naman, we know that they're very far from each other and they're freely moving. But please take note, not even solid na dikit-dikit yung mga particles, the particles are still moving. They are wiggling, so parang nanginginig lang sila sa mga pwesto nila. That's the only motion that's actually possible para sa mga solid material natin. At least sa liquid natin, medyo freely moving na sila. They can slide past to one another. Pero yung sa gas, they're freely moving inside a container or inside the system. Okay? So in this case, a gas adopts the container of a shape and fills it because its particles are far apart and move randomly. So as you can see here on our animation, the gas molecules are pretty freely moving inside the container and hence filling it. Okay? Uh, this is possible because their particles are far apart and they move randomly. Sa liquid, they also adapt the container shape to the extent of its volume. So for example, the volume of liquid is 10 ml, it will fill the container at exactly 10 ml. Unlike gas, for example, nakalagay sa container natin ay 10 ml na gas na ganyan, 10 ml yung container natin. We're not sure kung 10 ml ba talaga yung gas molecules na nandun. But we're sure that the container can contain 10 ml. So ibig sabihin, lumalabas na yung ating liquid container or liquid material has definite volume. Kung 10 ml yan, 10 ml yan. Kung 1 liter yan, 1 liter yan. Okay? This is because their particles are close together but they're free to move around each other. Okay? Unlike gas kanina that they're freely moving, they can actually occupy the space available inside the container but we are not sure on the volume na nilagay natin unless na lang talaga kung alam natin nilagay natin volume. So for example, may lobo tayo dyan nilagay natin. We're sure na shape niya is circle but we're not sure about the volume na nailagay natin sa container na yon. Sa solid materials naman, as you can see here, the particles are very near to each other. They're very rigid in arrangement and ang tanging kaya nilang gawin nila is to wiggle around. So parang nanginginig na lang nila sila sa mga pwesto nila. Okay? So they are held rigidly in place kaya lumalabas na yung mga solid material natin, typically they have definite volume and definite shape. So if you have a cube of gold, so kayang-kaya nating i-measure yung volume niyan and also yung bigat niyan and even the shape are also consistent or definite. Unlike yung ating liquid container, for example, naglagay tayo ng 1 liter ng tubig sa isang pitchel na cylindrical, it will conform to that shape of that cylinder. Pero pag nilagay natin yung ating liquid material sa isang flask, sabi natin yung Erlenmeyer flask na triangular yung conical shape siya, it will conform to that shape but the volume will remain the same as long as hindi natapon yung ating liquid habang nagsasalin tayo. Pero sa gas molecules natin or gas material natin, they do not have definite volume, they do not have definite shape. So moving on, as you can see here, this one is bromine. Doon nagkakamali. So bromine can exist, as you can see here, given at a very specific temperature, they can exist in three phases. So on this first one, let me yan. As you can see here on our diagram, this one is gaseous na bromine and the particles are far apart and they're freely moving. And they usually fill the available space. Kaya nga nafe-fill napupuno nila yung nilagyan pero hindi tayo sure sa volume. They have the indefinite volume. Sa liquid naman, which is the regular or the normal state of bromine at room temperature, particles are close together but move around one another. Pero once na nilagyan natin siya sa isang napakalamig na temperature, bromine will start to freeze and to form solid structure na alam natin. So the particles will now become closer together in a regular array and do not move around one another. The only thing that they can do is to wiggle around. So ang focus talaga ng ating discussion ngayon dito, since this one is all about gas laws, actually this is the introduction for gas laws, is actually gas. Okay? The gaseous state na inaano natin. So titignan natin sa next part ng ating discussion na ito, yung characteristics ng gas natin. So the first one here is gas volume changes insignificantly with pressure. As you can see here on our diagram, let me use a laser pointer. Okay? The piston, ito pong parang bumababang area na to, is going down. So pag lumilit yung ating space na yan, we are also increasing the pressure. Okay? So ibig sabihin pag lumilit na yung space na yan, we are confining the gas molecules inside a smaller space, we are also going to increase the pressure. So in this case, when a sample of gas is confined to a container of variable volume, Variable volume to kasi kaya nating baguhin yung volume ng ating container, such as this cylinder with piston. Increasing the force of the piston decreases the gas volume. And decreasing the gas volume may increase the pressure, which we're going to look further once we discuss gas law. So habang tumataas yung pressure, o yung force rather, and pinipress natin yung piston pababa, we are also decreasing the gas volume, yung space na available sa kanya. Okay? And in this case, kapag tinanggal naman natin yung force na yan, we are removing the external force, itinaas natin yung piston na yan, we are also increasing the volume again of the gas molecule o yung mismong gaseous material natin. Okay? So large container, the gas pressure is due to the moving gas particles colliding with the container walls. And if we are going to make the container smaller, okay, in the smaller volume, the gas particle collide with the container wall more often. Mas madalas na siyang babangga ngayon sa ating container. And this one, itong pagtaas ng frequency ng pagbangga or collision ng ating particles sa container ng ating gaseous material increases the pressure. Diba? Sa elevator kasi we are a fixed volume yan, pero once na dumadagdag na yung mga nilagay natin ng isang, for example, sabi natin na we have dapat sa classroom to gagawin. You have 10 students inside your classroom and they're asked to freely move around inside the classroom. So most probably, there's a less tendency na sila yung magbanggaan kasi malaki yung classroom natin. Pero if you put the same number of students inside a cubicle ng CR o mas maliit na container, mas maliit na lalagyan, mas malaki ang chance na sila ay magbungguan kasi mas maliit na yung space na nilalagyan nila. Okay? Actually, parang common sense lang eh. So if you have larger container, less yung bungguan. If you have smaller container, the tendency is to have a higher rate of collision. Okay? Next naman, the gas volume change significantly with temperature. Ito mga binabanggit kong concept na to, it's very important because this would be the foundation for our discussion for our gas laws na i-discuss natin sa mga susunod na araw. When a sample of gas is heated, it expands. Okay? That's the general rule. Kapag ito ay nilamigan naman, ito ay mag-shrink. Okay? This volume change is 50 to 100 times greater for gases than for liquids or solid. The expansion that occurs when gases are rapidly heated can have the dramatic effect like lifting a rocket into space and everyday ones like popping of popcorn. Okay? So for example here, pag malamig ang temperatura, the particles are very slow. So kung mabagal sila, maliit din ang chance na sila ay magbungguan kasi mabagal nga sila eh. Okay? So if you have low temperature, most probably you have low pressure. But if you increase the temperature of the material, nilagay natin sa isang mainit na environment, okay? There's a tendency na tataas din ang collision nila because the particles will start to move faster, thus increasing the pressure. Another concept is that gases flow very freely. Okay? Gases and liquids belong to the fluids. Pag sinabi natin fluid, these are flowing material, dumadaloy. So generally, gases flow much more freely than liquids and solids. This behavior allows gases to be transported more easily through pipes, but it also means they leak more rapidly out of small holes and cracks. Okay? Kaya normally, yung mga sa mga respirators natin sa ospital, yung mga tubes na dinadaanan ng oxygen, those gases can easily pass through those tubes, even they're small or they're very narrow, kasi gas can flow very freely. This will always go back to the structure of the particles o yung arrangement ng particles na yan. Yun nga lang, ang downside niyan, kahit maliit lang yung butas o sira ng tubo, maaring sumingaw yung ating gas. Which is very obvious sa mga napapanood natin mga pelikula na kung saan may mga tumatagas na mga gaseous material sa mga tubo, you're going to often to see na parang sumisirit yung gas molecules natin or gas particles natin out of that small cracks or small holes sa mga pipes na yun. Another thing is that gases have relatively low densities. Okay? Ibig kasi obviously hindi sila siksik. Okay? Kaya they have very low densities. Gas density is usually measured in units of grams per liter or G over L, whereas liquids and solids densities are in grams per milliliter, about 1,000 times as dense. So mas sabihin natin mas hiwa-hiwalay ang particles ng ating gas, contributing to this property na they have lower densities. When a gas cool, its density increases because its volume decreases. Obviously naman, kapag lumamig, sabi natin kanina, pag lumalamig daw, balikan natin yun this one, if you have lower temperature, the tendency is that we can actually, uh, the density will increase kasi magiging siksik yung mga molecules, the gas will shrink, okay? Therefore, decreasing the volume. And this may cool on cooling from 20 degrees to 0 degrees, and the density of oxygen gas increases from 1.3 to 1.4 grams per liter. Okay? So again, when gas cool, pag lumamig siya, magsishrink siya, the density will increase because its volume decreases. Okay? So in this diagram, as you can see here, kitang-kita natin yung pagkakaiba nitong case 1 at case 2. You have larger volume here. Okay? Malaki yung volume natin dito. It's 2 square meters. The mass of the material is 0.52 kilograms. And in this case, the density is 0.26 kilogram per cubic meter. Sa case number 2 natin, we have the same volume. Okay? It's 0.26 kilograms per meter cube. Pero pag niliitan natin ang volume with the same amount of gas particles, you can see there natataas din po ang density niya. So in this case, these are some of the gases form a solution in any proportion. Sa totoo lang, yung air na nilalanghap natin is actually a solution of 18 gases. 2 liquids, however, may not form a solution. Water and ethanol do, but water and gasoline do not. So 2 solids generally do not form a solution unless they are melted, then allowed to solidify. Pero yung gas natin, they can easily mix together. Sabi nga natin dito, air is actually a solution of 18 gases. Nila lang po Pabalik lang po sa platform. Yan. So I think na-discuss na to dapat na to ng grade 7 sa environmental science ninyo and as well as sa grade 7 science ninyo. This pie chart shows you that the air that we are breathing right now is actually a mixture of multitude of gases, wherein nitrogen encompass about 78%, oxygen is about 20%. In other gaseous substances like carbon dioxide, inert gases like argon and water vapor comprises a little bit of about 2% ng ating air. But as you can see here sa ating graph, it's a mixture of gases, yung air natin. So the first properties, since nababanggitan natin kanina paulit-ulit, one of the things that actually changes sa ating gas is your pressure. So gas particles move randomly within a container with relatively high velocities. Mabibilis ang galaw nila. Okay? So dahil mabilis sila, they have higher tendency na sila ay bumunggo sa walls ng ating container. And once na ito ay nangyari, itong pagbunggo nila sa wall ng ating container exerts certain amount of force over a unit of area. And this one is equal to the pressure. So when we say pressure, it's actually force over area. So if you have lower pressure, you have, sabihin natin, kaunting collision ang nangyayari. Pero pag high pressure, you have larger number of collision, bumping or colliding sa ating wall. So gases in the atmosphere exert a force or weight uniformly on all surfaces. So right now, even you're sitting right now, even na hindi natin nararamdaman yan, our atmosphere is exerting a certain amount of force. And this kind of pressure is what we call the atmospheric pressure. And this atmospheric pressure is typically equivalent to 14.7 pounds per square inch or PSI. And I think naririnig nyo na to sa itong word na PSI na to kasi sa Facebook pa lang may mga reels doon na kung saan nagpapakita sila ng yung hydraulic pistons and they use the unit PSI. Yung dinudurog nila yung mga material, yung mga object for views, for react sa FB. So they are using the unit PSI or pound per square inch. So a pressure of 14.7 pound per square inch exists on the outside of your room and it equals the pressure on the inside. So yun yung normal. So ibig sabihin kung ang pressure natin sa labas is 14.7 PSI, dapat yung ating pressure sa loob is also 14.7 PSI. So tingnan natin itong diagram na ito. We have a vacuum and this vacuum is attached with a tube in a container na may cap, nasiselyuhan yung cap na yan. And if the vacuum is off, walang pressure, walang humihigop ng pressure na yan, yung material na yan, walang humihigop sa mga gas molecules na yan, the pressure outside and inside are equal. But the different story will happen if we turn on the vacuum. The vacuum will now suck all the gas material, thus the pressure inside decreases. Dahil mababa na ang pressure sa loob, yung pressure niya sa labas ay mas malakas, pipit-pitin ngayon ng ating pressure outside yung ating container. Kaya napansin nyo dito sa ating diagram, napitpit yung ating or natutupi, nayupi yung ating lata. Because the pressure outside is greater than the pressure inside. So how are we going to measure atmospheric pressure? Atmospheric pressure is normally normally measured using barometer. At sea level, like the one we have right now, itong nasa mga elevation natin, the ordinary atmospheric condition, okay, the mercury stops flowing out when the surface of the mercury in the tube is about 760 millimeters above the surface of the mercury in the dish. So, ibig sabihin, this tube, let's zoom this. Yan. So we have a dish filled with mercury, attached is a closed tube with a vacuum at the end, and the pressure na dumadagan ngayon o na-exert sa ating dish is also equivalent to the amount of atmospheric pressure. And this downward force will actually push the liquid mercury, or rather the mercury, inside our tube. Yun nga lang, if you have a pressure under normal condition, okay, that amount will equate to 760 millimeters. So itong 760 millimeters na ito is the amount of atmospheric pressure exerted by the atmosphere towards our mercury barometer. So at that height, the column of mercury exerts the same pressure on the mercury surface in the dish as the atmosphere does. So the height of the mercury, or rather the pressure of mercury, is also equivalent to pressure of the atmospheric pressure. Okay? So here are some of the units of pressure that you're going to ma-encounter natin sa mga susunod nating discussion. And I do hope that you know how to convert. Okay? Kasi yan ang ipapa-activity ko sa inyo later. You're going to convert some of these units of pressure. So we have Pascal, atmosphere, ATM, millimeters of mercury or mmHg, torr, pound per square inch, and bar. Most probably may encounter nyo sa mga activities natin will be ATM, millimeters of mercury, torr, and PSI. Yan yung kadalasang may encounter natin. So the pressure of the mercury column is directly proportional to its height. A unit commonly used for pressure is millimeters of mercury. So itinataas ng mercury sa ating tubo is equivalent to the amount of pressure present, or actually yung nag-press down sa mercury naman sa ating dish. Sa sea level and at 0 degrees Celsius, normal atmospheric pressure is 760 millimeters of mercury. Pero habang tayo ay tumataas, yung ating pressure also decreases, turning it to 270 millimeters of mercury. So, sa ating mga experiments, you're not going to use anymore yung mercury barometer. Okay? You're going to use manometer. Manometer is actually a device that can use that we use to measure the pressure of a gas in an experiment. It's actually a form of barometer, but this one is intended only for gas molecule. So in this case, we have two types of manometer. We have the closed end and the open end manometer. So sa closed-end manometer, obviously, close yung nasa dulo natin. In this case, sa ating diagram, let's zoom. As you can see here sa ating diagram, we have an evacuated flask connected to a container of gas. Once we open at ipinasok na natin yung gas na yan, they will start to occupy the space available hanggang sila ay mag-push sa ating mercury. In this case, at the start of the experiment, the amount of mercury is the same. Okay? Pero once na naglagay na tayo ng gas sa ating evacuated flask, the gas molecule or the gas particle or the gas material will now start to exert certain amount of pressure. And that pressure will make this mercury to move downward at yung dulo naman niya ay tumaas. Itong change in height na ito is actually equivalent to the amount of pressure present or exerted by the gas molecule natin. So, in this case, this concept will be further elaborated once we have now the computation for the gas laws. So, yung mga na-discuss natin mga properties, mga ganyan, is actually will be very helpful for you to understand the gas laws. So, this would end my presentation for this moment. Okay? So, let me go back to my presentation. Again, the attendance will be checked through sa pamamagitan ng pagta-type ninyo ng inyong surname sa ating comment section. But I do hope that you watch this one kasi let me remind you na medyo mababa po yung grade ninyo ng third grading sa science. Okay? So, without further ado, this would end my discussion. So, the activities, ibibigay ko na lang po, I think later. Or kung hindi man po kaya later, I think before mag-Thursday po. Okay? So, maraming salamat po. Goodbye.